Mid-November, 1942. El Guettar, Tunisia. The sun was descending in a pale orange glow across the scrub-covered ridges of the Tunisian front, casting long shadows over the churned battlefield where wrecked vehicles and abandoned equipment testified to another brutal day of fighting. Scattered among the cartridge casings and shrapnel lay something that caught the eye of a German officer, a rifle, partly buried in the ochre sand, its walnut stock and Parkerized steel glinting faintly in the fading light. It was unlike anything he had seen issued to his own infantry. The weapon was swiftly recovered and wiped clean. It bore the markings of Springfield Armory, the oldest arsenal in the United States, and a serial number, U-23,000. Gesint. The officers from the 15th Panzer Division's reconnaissance battalion exchanged glances. The serial number placed the rifle among the latest examples produced in early 1942, meaning that it had been manufactured only months before arriving here on the African continent. A weapon conceived, built, shipped across an ocean, issued to a soldier, and now lying in North African sand, all in less than a year. There was a message in that speed. Before we jump back in, tell us where you're tuning in from, and if this story touches you, make sure you're subscribed because tomorrow I've saved something extra special for you too. But what held their attention most was not its origin, but its design. This was no bolt-action rifle, no carabiner 98k, no weapon reliant on manually cycling a bolt after every shot. This rifle, the US M1 Garand, was semi-automatic. 8 rounds of .30-06 ammunition loaded into an internal magazine using an M-block clip, fired as fast as the shooter could pull the trigger. No bolt to lift, no handle to pull, no chamber to close. Just point, fire, repeat. The German officers turned it over with fascination. They noted the gas-operated action, the smooth mechanism, and the absence of a traditional bolt handle. In its place, an operating rod allowed automatic cycling, ejecting spent casings and chambering fresh rounds in a seamless rhythm. They saw the aperture rear sight and front post, superior to their own open sights, in both precision and speed of alignment. They felt the balance of the rifle, sturdy yet surprisingly well fitted for rapid, controlled fire. For the Germans, this weapon was not just a curiosity, it was a problem. For years, German military theorists had debated the concept of a semi-automatic rifle as the future of infantry warfare. They believed in the idea, but could not deliver the weapon. Their small arms industry lacked the mass production capability to produce such rifles in the millions, and their logistical doctrine still assumed infantry combat would revolve around squad-based machine gun tactics. The individual rifleman, in German doctrine, delivered supporting fire, never decisive fire. Superior marksmanship and discipline mattered more than rate of fire, at least according to the textbooks. But the battlefield was rewriting the textbooks. American soldiers equipped with the M1 Garand were delivering volumes of accurate fire previously unimaginable from individual riflemen. American infantry squads now had a staggering amount of organic firepower without depending solely on machine guns. A single US rifle platoon could unleash sustained, accurate, semi-automatic fire at ranges where German troops were forced to manually operate their bolt-action carabiners. This was not simply a difference in the weaponry. It was a shift in philosophy, a shift in lethality, a shift in the speed of engagement. One of the German officers, Hauptmann Dietrich, was an instructor before the war. He had lectured on advanced infantry tactics and once argued that mass-produced semi-automatic rifles would be impractical for a modern army, too complex to maintain and too expensive to issue. Now, staring at this captured weapon, he realized the truth. The Americans had solved the complications, industrial, mechanical, and logistical, and in doing so, they had changed the equation of infantry combat. The M1 Garand was not perfect. It was heavier than the Kar98k. Sand could sometimes interfere with the action if not cleaned regularly. Its on-block clip system made topping off ammunition difficult, but these disadvantages paled in comparison to its decisive advantage: rate of fire, without sacrifice in accuracy. A trained American rifleman could deliver aimed shots 2 to 3 times faster than his German counterpart. Multiply that across 10 men, then 40, then 400, and the outcome was no longer tactical. It was operational. The Germans had prototypes, such as the G41 and later the G43, but these were built in limited numbers. They were complicated, fragile, difficult to mass produce, and often unreliable in harsh conditions. American weapons, by contrast, were built with mass production at the core of their design. The M1 Garand was engineered not only for performance, but for scale. Interchangeable parts, simplified machining, rapid manufacturing, ease of maintenance. These were the hallmarks of American military industry. Even the markings impressed the German evaluators. Where German rifles often bore stamped codes to conceal factory origin for intelligence secrecy, the American weapon openly displayed its maker, Springfield Armory, as if to announce, without modesty, the existence of an industrial giant that had faith in its capacity, confidence in its quality, and no fear of enemy analysis. That was the difference. Germany produced weapons. America produced a system. War had become a contest of systems. German intelligence had received reports of these rifles before, but many officers had dismissed the accounts as exaggerated. Now, holding one in their hands, those dismissed reports came alive. They were no longer theoretical. They were physical. They were here, and they were now. Young lieutenant asked a question quietly, as though speaking too loudly might expose something deeper. "Imagine," he said, "if every American infantryman carries one of these." The group fell silent. It was not just a weapon. It was a warning, a weapon that embodied industrial superiority and tactical adaptability and strategic foresight. A rifle that signaled America's war was not one of brilliance and improvisation, but of overwhelming efficiency and enduring production. The M1 Garand meant that the Americans would not fight Germany with the weapons of 1914. They would fight with the weapons of 1944 and beyond. This rifle lay in the sand beside an American soldier who would never rise to reclaim it. But his weapon would rise, examined, measured, feared, and soon it would return to battle in the hands of 2 million more, just like him. In the deserts of Tunisia, under the pale November sun, the future of infantry warfare did not arrive with thunder or fanfare. It arrived quietly, in the form of a rifle, resting in the sand. The Garand weighed approximately 4.5 kilograms loaded, comparable to the Carabiner 98 Kars that equipped German infantry. The overall length measured 110 centimeters, again similar to German service rifles. But the operating mechanism revealed fundamental differences that would dominate German technical analysis for years. Where the Kar98k required manual operation of a bolt action between each shot, the Garand fired one round with each trigger pull, automatically ejecting spent casings and chambering fresh rounds until the 8-round unblock clip was exhausted. German small arms experts had long understood the theoretical advantages of semi-automatic infantry rifles: higher sustained rates of fire without the interruption of manual cycling, reduced training time for basic marksmanship since soldiers maintained sight picture between shots, enhanced tactical flexibility, allowing individual riflemen to suppress enemy positions that would require multiple bolt-action riflemen. German ordnance departments had pursued semi-automatic rifle development since the 1920s, with multiple prototypes reaching limited production. None had achieved the reliability or manufacturing efficiency necessary for mass issue to frontline infantry units. The captured Garand was packed carefully for shipment to Germany, along with several additional rifles recovered intact from American positions. The Waffenamt, Germany's weapons procurement office, issued explicit instructions. These rifles must reach the testing facility at Kummersdorf intact and functional. German engineers needed to understand how American industry had solved problems that continued frustrating German small arms designers despite decades of effort and substantial resources devoted to to semi-automatic rifle development. Spring 1943 Kummersdorf Proving Ground. Brandenburg, Germany. The M1 Garand, designated Prüfgerät 283, rolled off the wooden shipping crate onto the examination table at Germany's primary weapons testing facility. Test engineers had already prepared comprehensive evaluation protocols designed to stress every component and assess reliability under conditions replicating combat operations. Kummersdorf, located 25 kilometers south of Berlin, served as the hub for German weapons development and captured Allied equipment analysis. Here, methodical engineers measured, tested, and documented everything from trigger pull weights to gas system pressure curves. The initial inspection revealed construction techniques that seemed impossibly straightforward compared to German manufacturing practices. German test engineers photographed every component from multiple angles, measured every dimension with precision instruments, and documented assembly methods that prioritized simplicity over theoretical optimization. The receiver was machined from a single forging, a production method that required substantial machine tool capacity, but resulted in exceptional strength and dimensional stability. German rifles typically used multiple components pinned or screwed together, a technique that demanded less sophisticated machinery, but introduced more potential points of failure. The gas operating system caught immediate attention from German ordnance specialists. The Garand used a long-stroke gas piston that traveled with the bolt carrier, a design that absorbed recoil energy while cycling the action. German engineers had experimented with similar systems, but consistently encountered reliability problems related to gas, port fouling, piston binding, or inconsistent cycling under varying ammunition loads and environmental conditions. The Garand's gas system appeared remarkably simple in design, yet demonstrated exceptional reliability during initial function testing. The en-bloc clip loading system provoked intense technical debate among German evaluators. The 8-round clip inserted into the receiver from above, held by a clip latch that retained it during firing and ejected it automatically after the final round fired. This system allowed rapid reloading compared to stripper clips used with bolt-action rifles, which required feeding individual rounds into an internal magazine. German observers noted both advantages and disadvantages. The en-bloc system permitted faster tactical reloads under combat stress. However, it required dedicated manufacturing capacity for clips and limited riflemen to 8-round loadings rather than variable quantities. Testing began with basic function trials designed to verify reliable operation under controlled conditions. Engineers fired the Garand through hundreds of rounds, recording every malfunction, measuring gas system pressures, and monitoring component wear. They tested the rifle at temperature extremes, documenting performance in cold that would disable poorly designed weapons and heat that would cause others to malfunction from expansion-related binding. They deliberately introduced fouling by firing extended strings without cleaning, assessing how carbon buildup affected reliability. The results contradicted German assumptions about the trade-offs necessary to achieve semi-automatic operation in a service rifle. The Garand functioned reliably across temperature ranges that would cause German semi-automatic prototypes to fail. It maintained consistent cycling through hundreds of rounds between cleanings, far exceeding what German designs achieved. It demonstrated exceptional resistance to battlefield fouling that would jam German weapons, requiring factory-level maintenance to restore function. Every test reinforced the same conclusion. American engineers had solved fundamental reliability problems that continued plaguing German semi-automatic rifle development. The comparison with German service rifles became unavoidable as testing data accumulated. The Karabiner 98 Kurz represented the pinnacle of German bolt-action rifle development, a weapon renowned for accuracy, reliability, and robust construction. As a bolt-action design, it was essentially unimprovable, having reached maturity through decades of refinement, but it remained fundamentally limited by manual operation that required shooters to break their sight, picture, operate the bolt, reacquire their target, and fire again. Even highly trained riflemen could manage only 15 to 20 aim shots per minute with bolt-action rifles under ideal conditions. Combat stress, difficult positions, and target movement reduced practical rates considerably. The M1 Garand, by contrast, allowed trained riflemen to fire 30 to 40 aim shots per minute, essentially doubling practical firepower compared to bolt-action rifles. This advantage multiplied across an entire infantry squad equipped with 8 M1 rifles, compared to a German squad armed with bolt-action Kar98k rifles. American infantry could deliver roughly twice the volume of rifle fire, fundamentally altering tactical calculations about fire superiority and suppression. Summer 1943 expanded testing program. Additional captured Garands arrived at Kummersdorf throughout 1943 as American forces expanded operations in North Africa, Sicily, and Italy. Each rifle underwent similar testing protocols, building a comprehensive database of American small arms capabilities across different production periods and manufacturing sources. Springfield Armory rifles were compared with Winchester-manufactured examples, examining whether quality or specifications varied between producers. German engineers found no significant differences. American manufacturers produced two identical specifications with fully interchangeable parts, a standardization that German industry struggled to achieve even within single factories. Telling and preparing this story took us a lot of time. So, if you are enjoying it, subscribe to our channel. It means a lot to us. Now, back to the story. The Winchester M1 Garands particularly impressed German evaluators. Winchester Repeating Arms Company had transitioned from producing sporting firearms and Winchester 97 shotguns to manufacturing military rifles using the same mass production principles they had developed over decades of commercial production. The rifles demonstrated identical function and reliability to Springfield Armory production, despite coming from a manufacturer that had never produced military weapons on government contract before the war. This manufacturing flexibility, routine in American industry, remained largely theoretical in German wartime production, where each manufacturer introduced subtle variations that prevented true parts interchangeability. German small arms designers studied the Garand's operating system in exhaustive detail, conducting metallurgical analysis of critical components to understand material selection and heat treatment processes. The operating rod demonstrated exceptional toughness despite appearing relatively simple in design. German engineers discovered that American metallurgists had specified alloy steels with carefully controlled heat treatment that provided optimal combinations of strength and ductility. German prototype rifles frequently suffered operating rod failures because designers specified inadequate materials or manufacturing processes failed to achieve consistent heat treatment. The trigger mechanism revealed design sophistication that belied its apparent simplicity. The Garand's two-stage trigger provided a crisp break that facilitated accurate shooting while maintaining sufficient robustness to function reliably under combat conditions. German engineers noted that the trigger components required relatively loose tolerances by German precision standards, yet produced consistent performance across all tested rifles. American designers had engineered deliberate clearances that prevented binding from dirt, sand, or carbon fouling while maintaining functional accuracy. German prototype designs typically specified tighter tolerances that looked impressive in technical drawings but proved problematic when exposed to battlefield conditions. The gas system examination revealed why American designs succeeded where German efforts failed. The Garand's gas port and cylinder dimensions had been carefully optimized through extensive testing to provide reliable cycling across a broad range of ammunition variations and environmental conditions. The gas system included sufficient excess capacity to function reliably, even when partially fouled or when using ammunition at the lower end of acceptable pressure specifications. German designers, by contrast, typically calculated gas system dimensions to minimum necessary specifications, pursuing theoretical efficiency at the cost of practical reliability margins. This engineering philosophy worked acceptably in laboratory conditions, but failed to account for combat realities where weapons operated with variable ammunition, inadequate cleaning, and extreme environmental exposure. Autumn 1943. Comparative field testing. Kummersdorf engineers conducted extensive field trials comparing the M1 Garand with German service rifles and semi-automatic rifle prototypes. Test teams fired thousands of rounds through combat simulation courses designed to replicate infantry engagement scenarios. They measured hit probabilities at varying ranges, timed magazine changes and sustained fire drills, and assessed how fatigue affected shooting performance over extended periods. The data documented advantages that transformed tactical infantry doctrine. In timed fire exercises, simulating suppressive fire against enemy positions, riflemen armed with M1 Garands delivered approximately double the rounds on target compared to equally trained shooters using Kar98k bolt-action rifles. The difference became more pronounced as engagement duration increased and shooter fatigue accumulated. Operating a bolt-action required physical effort that accumulated over dozens or hundreds of repetitions, degrading accuracy and slowing fire rates. Semi-automatic operation required only trigger manipulation, allowing shooters to maintain consistent performance through extended engagements. Tactical reload times demonstrated another significant advantage. The on-block clip system allowed trained soldiers to reload in approximately 2 to 3 seconds, far faster than the 5 to 10 seconds required to reload a Kar98k using stripper clips. This difference mattered critically during firefights when opponents attempted to time their maneuvers to coincide with enemy reloading pauses. American riflemen armed with Garands could sustain nearly continuous fire that prevented enemy movement, while German bolt-action riflemen created predictable gaps during reloading that opponents could exploit tactically. Accuracy testing revealed that the Garand matched or exceeded Kar98k precision at combat ranges, despite being semi-automatic. German engineers had assumed that semi-automatic operation would inherently sacrifice accuracy compared to manually operated bolt actions. The Garand disproved this assumption through careful design that isolated barrel vibrations from operating components and maintained consistent lockup between the bolt and barrel extension. At ranges beyond 400 meters, factors other than mechanical precision dominated accuracy, and under those conditions, the Garand's ability to fire rapid follow-up shots provided significant advantages for engaging moving targets or correcting point of aim. The field testing program expanded to include deliberate abuse designed to simulate worst-case combat conditions. Test rifles were dropped repeatedly onto concrete, submerged in mud, exposed to rain and snow, and fired extensively without cleaning until carbon fouling accumulated heavily throughout the action. The Garands continued functioning with remarkable consistency, requiring only occasional cleaning of the gas cylinder to maintain reliable operation. German semi-automatic prototypes, tested under identical conditions, failed consistently, demonstrating sensitivity to battlefield conditions that would render them unreliable in actual combat service. Internal German semi-automatic rifle development. The Garand testing program occurred simultaneously with German efforts to develop their own semi-automatic service rifles. The Gewehr 41, developed by Mauser and Walter companies, represented Germany's first serious attempt at a semi-automatic infantry rifle. Both variants used complex mechanisms substantially different from the Garand's design. The Mauser G41 employed an unusual muzzle cone system that trapped propellant gases to cycle the action, while the Walther G41 used a similar system with different implementation details. Neither design proved satisfactory in field service. The G41 rifles suffered from excessive complexity that made them difficult to manufacture and maintain. The muzzle cone system proved sensitive to barrel fouling and would cease functioning reliably after relatively few rounds without thorough cleaning. Weight exceeded 5 kilograms, substantially heavier than the Garand, despite offering no performance advantages. Manufacturing required skilled labor and precision machining that German industry increasingly lacked, as experienced workers were conscripted for military service and replaced with forced laborers who had neither training nor motivation to produce quality work. Field reports from units issued G41 rifles in 1942 and 1943 documented consistent reliability problems. Soldiers reported frequent stoppages requiring immediate maintenance to restore function. The muzzle cone system accumulated carbon deposits that blocked gas ports, causing failures to cycle that left soldiers with single-shot rifles requiring manual operation to eject spent cases and chamber fresh rounds. Under combat stress, many soldiers abandoned their G41 rifles in favor of captured Soviet or other weapons that function more reliably despite being enemy equipment. This pattern repeated what Kummersdorf testing revealed about American versus German design philosophy. German engineers pursued theoretically elegant solutions that minimized moving parts and met impressive specifications on paper. American engineers designed for practical reliability, accepting greater complexity if it provided robustness under field conditions. The Garand used more components than German designs, but each component performed a clearly defined function with adequate margins to tolerate battlefield fouling, ammunition variations, and operator error that inevitably occurred in combat. The Gewehr 43 represented Germany's second attempt at a semi-automatic service rifle, incorporating lessons from G41 failures and analysis of captured Soviet Tokarev SVT-40 rifles. The G43 abandoned the problematic muzzle cone system in favor of a gas-operated design, more similar to the Garand's operating principles. German engineers studied the captured M1 rifles at Kummersdorf extensively during G43 development, attempting to understand why American designs succeeded where German efforts continued failing. The G43 showed improvement over the G41, demonstrating better reliability and reduced weight. However, it never matched Garand performance in systematic comparative testing. German manufacturing quality degraded throughout 1943 and 1944 as Allied bombing disrupted production facilities and material shortages forced substitution of inferior alloys. Late-war G43 rifles suffered from inconsistent heat treatment, poorly finished components, and assembly defects that would have been unacceptable in earlier production but became routine as German industry collapsed under sustained bombing and material shortages. 1944 Tactical Implications and Field Reports. By mid-1944, German infantry units facing American forces in Italy and France reported consistent firepower disadvantages when engaging at ranges where individual rifle fire determined tactical outcomes. American infantry squads could deliver sustained volumes of fire that suppressed German positions and prevented effective return fire. German squads, armed with bolt-action rifles, required substantially more soldiers to match American firepower, creating a numerical disadvantage that compounded Germany's strategic manpower shortages. After-action reports from German commanders noted that American infantry could sustain offensive pressure that forced German units to withdraw or surrender even when holding theoretically advantageous defensive positions. The firepower differential created by semi-automatic rifles allowed American forces to fix German units in place with suppressive fire, while maneuver elements flanked and overran positions. German infantry, armed with bolt-action rifles, lacked the firepower to simultaneously suppress attackers and repel flanking movements, forcing tactical choices that frequently resulted in position loss. The comparison became more painful as German rifle production struggled with increasing material shortages and manufacturing difficulties. Kar98k production, though relatively simple compared to semi-automatic rifles, still required skilled labor and quality materials that became increasingly scarce throughout 1944 and 1945. Late-war production rifles showed degraded finish, substitution of inferior materials, and occasional functional problems that would have been unacceptable in earlier production periods. These problems affected even simple bolt-action rifles, highlighting how thoroughly Allied strategic bombing and material shortages had devastated German industrial capacity. Meanwhile, American M1 Garand production continued at scales that German industry could never approach. The United States produced approximately sold 1 million M1 Garands during the war, more than all German rifle production of all types combined, while simultaneously producing M1 carbines, M1918 Browning automatic rifles, Thompson submachine guns, and other small arms in massive quantities. American factories operated safely beyond any combat threat, staffed by motivated workers, earning good wages under decent conditions. supplied with abundant raw materials and electrical power, and supported by comprehensive machine tool industries that provided whatever specialized equipment manufacturers required. German small arms factories operated under constant threat from Allied bombing, staffed increasingly by slave laborers who had neither training nor motivation to produce quality work, chronically short of critical materials and electrical power, and struggling with worn-out machine tools that couldn't be replaced because machine tool factories were being bombed or diverted to produce other critical war materials. Technical analysis and engineering conclusions. By late 1944, Kummersdorf had accumulated comprehensive technical data documenting why American semi-automatic rifle development succeeded while German efforts failed. Internal reports circulated through Waffenamt technical branches painted a sobering picture of comparative capabilities. The Americans possessed several decisive advantages that Germany fundamentally lacked despite comparable theoretical engineering knowledge. American small arms designers drew upon decades of civilian firearms manufacturing experience that Germany had never developed at comparable scale. Before the war, American commercial firearms manufacturers produced millions of rifles, shotguns, and handguns annually for civilian markets. This created deep industrial expertise in manufacturing techniques, material science, and quality control processes that transferred directly to military production. Companies like Winchester, Remington, and Savage Arms understood how to design weapons that ordinary factory workers could manufacture consistently using available machine tools and materials. Germany had far more limited civilian firearms manufacturing, with production concentrated in a few firms producing primarily for military contracts and export markets. The Weimar Republic's restrictions on civilian firearms ownership under the Versailles Treaty further limited domestic market development. German firearms designers possessed extensive theoretical knowledge, but lacked the practical manufacturing experience that American industry had accumulated through decades of commercial production. The Garand's design reflected this manufacturing maturity in countless details. Components were designed with generous tolerances that prevented binding from normal dimensional variations inevitable in mass production. Assembly processes used simple fixtures and standardized procedures that minimized required worker skill. Critical components, like the operating rod and bolt, were designed to tolerate substantial abuse without failure, incorporating safety margins that seemed wasteful by German efficiency standards but proved essential for battlefield reliability. German prototype rifles typically specified tighter tolerances that looked impressive in technical documentation, but proved difficult to maintain across large production runs. Components were often designed to theoretical minimum dimensions that reduced material consumption, but eliminated safety margins necessary for reliable field performance. Assembly processes frequently required hand-fitting and adjustment by skilled craftsmen, making mass production problematic even when material and machine tool availability weren't constrained. The metallurgical analysis revealed another critical American advantage. The Garand's steel components used relatively simple alloy compositions that were easy to manufacture consistently and responded predictably to standard heat treatment processes. American metallurgists had specified steels that provided adequate performance while tolerating the variations in composition and heat treatment inevitable in large-scale production. German designers, by contrast, often specified exotic alloy steels that provided marginally better theoretical performance but proved difficult to manufacture consistently and required precise heat treatment that was hard to achieve in production conditions. 1945. Final assessments. As the war entered its final months, German use of captured American weapons became increasingly common as domestic production collapsed and supply systems disintegrated. German soldiers armed themselves with whatever weapons they could obtain, often preferring captured American equipment to German-issue arms because of superior reliability and ammunition availability from captured stockpiles. M1 Garands appeared frequently in German hands during final battles, providing one last real-world comparison under actual combat conditions. German soldiers who used captured Garands universally praised the rifle's reliability and firepower in letters, reports, and post-war interviews. Soldiers accustomed to Kar98k bolt-action rifles found the semi-automatic operation revelatory, allowing them to engage multiple targets rapidly or deliver sustained suppressive fire that would require an entire squad armed with bolt-action rifles. The en-bloc clip loading, initially unfamiliar, proved faster and simpler than stripper clip systems once soldiers practiced the technique. Even late in the war, when captured ammunition became scarce, German soldiers preferred carrying Garands when they could obtain .30 caliber cartridges. The reliability advantage became especially pronounced as German weapons suffered from degraded manufacturing quality and lack of proper maintenance due to lubricant and cleaning material shortages. Late-war German rifles frequently malfunctioned from accumulated fouling or component wear that couldn't be repaired because spare parts were unavailable. Captured Garands continued functioning with minimal maintenance, requiring only occasional cleaning of the gas system to maintain reliable operation. German soldiers noted that American weapons seemed designed to function even when neglected, while German weapons required constant expert attention to remain operational. Kummersdorf testing facility prepared for evacuation in early 1945 as Soviet forces advanced toward Berlin. Engineers packed testing data and shipped documentation westward, hoping to preserve technical intelligence for post-war analysis. Some captured Garands were pressed into improvised service with Volkssturm units desperately defending the approaches to Berlin. These rifles continued operating reliably until destroyed by enemy fire or abandoned when ammunition supplies were exhausted. Post-war implications and legacy. The story of captured M1 Garands tested at Kummersdorf represents one of the great small arms development disparities of World War II. German engineers working within an industrial system that prioritized theoretical elegance over practical utility pursued semi-automatic rifle designs that looked sophisticated on paper but failed in field service. American engineers, applying decades of firearms manufacturing experience to military requirements, produced rifles that achieved reliable semi-automatic operation through sound design principles, adequate safety margins, and manufacturing processes proven in commercial production. Post-war analysis by American and British intelligence organizations confirmed what German testing at Kummersdorf revealed. The M1 Garand represented a revolutionary advance in infantry small arms that fundamentally altered tactical doctrine and combat effectiveness. American infantry, equipped with semi-automatic rifles, possessed roughly double the individual firepower of opponents armed with bolt-action rifles, a differential that determined tactical outcomes in countless engagements throughout the war. The lessons learned through Garand evaluation directly influenced German small arms thinking in the post-war Bundeswehr. When the Federal Republic of Germany began developing the G3 battle rifle in the 1950s, designers consciously emphasized reliability and ease of manufacture over theoretical optimization. They studied American design principles and deliberately applied them to military rifle development. The resulting G3 incorporated many philosophies that made the Garand successful: robust construction with adequate safety margins, simple operating systems requiring minimal maintenance, and manufacturing processes using standard industrial materials and heat treatments. The G3 became one of the most successful battle rifle designs of the Cold War era, serving with dozens of armies and remaining in production for decades. Its success vindicated the design approach that German engineers had rejected during World War II, but finally embraced after experiencing the consequences of their earlier philosophy when confronting American weapons in combat. The captured Garands at Kummersdorf represented far more than enemy equipment brought home for technical examination. They were tangible proof that practical engineering, based on manufacturing experience and battlefield reality, produced better weapons than theoretical sophistication pursued without regard to production capability or field reliability. German small arms designers pursued advanced mechanisms because They believed superior technology could overcome material disadvantages and manufacturing limitations. They were wrong. American designers built reliable weapons because they understood through practical experience that sustained function under combat conditions determined effectiveness, regardless of theoretical performance specifications. They were right, and their approach proved decisive. The firepower gap between Garand-equipped American infantry and German infantry, armed with bolt-action rifles, fundamentally shaped tactical outcomes throughout the war's final years. This differential influenced not just individual combat engagements, but broader understanding of infantry weapons development and the decisive importance of reliability over theoretical performance. Germany entered World War II with extensive small arms expertise and scientific knowledge that equaled or exceeded any opponent. However, Germany lacked the industrial maturity and manufacturing sophistication to translate that knowledge into practical weapons that soldiers could rely upon in combat. The United States entered the war having already fielded a semi-automatic service rifle, achieving standards that Germany never matched, despite continued development efforts throughout the conflict. American industry produced these rifles in overwhelming quantities while maintaining consistent quality and continuously incorporating improvements based on combat feedback. This industrial achievement, impossible for Germany to replicate even before strategic bombing intensified, decided countless infantry engagements and contributed substantially to Allied victory. The mathematics were brutally simple when examined objectively. An American infantryman armed with an M1 Garand could deliver roughly twice the aimed fire of a German soldier with a Kar98k, fundamentally altering tactical calculations about fire superiority, suppression, and assault effectiveness. An American infantry squad with 8 Garands possessed firepower roughly equivalent to a German squad twice its size, creating numerical advantages that compounded Germany's strategic manpower shortages. Reliability wasn't merely a secondary consideration or convenience factor. It was the foundation of operational effectiveness, determining whether infantry weapons functioned when needed most. German weapons, even when theoretically sophisticated, consistently failed this fundamental test. American weapons consistently passed it. Kummersdorf testing proved this beyond reasonable doubt by mid-1943, even as German soldiers continued carrying bolt-action rifles into combat against opponents equipped with superior semi-automatic weapons. The M1 Garand didn't win World War II through any single technical advantage. It won through industrial superiority expressed as reliable semi-automatic operation, consistent manufacturing quality, and design philosophy that prioritized battlefield function over theoretical specifications. German engineers at Kummersdorf understood this based on exhaustive testing. They wrote detailed reports documenting their findings. They reached correct conclusions about American advantages, but understanding a problem and solving it are fundamentally different challenges. German industry lacked capacity to implement semi-automatic rifle production successfully while simultaneously fighting a losing war on multiple fronts. American industry had perfected semi-automatic rifle design and manufacturing before the war began, simply extending mature principles to mass military production with remarkable success. The captured M1 Garand rifles, tested at Kummersdorf, told a story far more profound than their simple lines of walnut and steel might suggest. To the untrained eye, they were merely rifles, mechanical tools of war, roughly the same size as any other service weapon, with a stock, a barrel, and a receiver. Yet, to the engineers and officers who stood in the testing halls of Kummersdorf, they spoke in a language that was unmistakably clear. They told a story of industrial power, engineering foresight, and a systemic approach to warfare that Germany had not matched and could not hope to match in the foreseeable future. Each rifle was examined meticulously. From the moment the Garand was unpacked, tested, and disassembled, every component revealed a meticulous balance of durability and simplicity. Springs, gas pistons, locking lugs, and en-bloc clips, all designed to function under battlefield conditions, were engineered for reliability rather than elegance, for performance rather than doctrinal experimentation. German engineers, schooled in the high ideals of mechanical sophistication, initially approached the weapons with a mixture of curiosity and condescension. They expected to find fragile components, clever but impractical solutions, or an over-reliance on precision machining that could not be scaled. What they found instead was a robust, resilient system that performed consistently under rigorous testing conditions. Every round fired without a malfunction, every clip smoothly loaded and ejected was an unspoken indictment of the path German small arms development had pursued. German engineers had prided themselves on technological complexity, on innovations that often produced elegant but finicky systems. Bolt-action rifles, such as the Kar98k, were mechanically beautiful in a textbook sense, but their rate of fire was limited, and their effectiveness depended upon the skill and discipline of the shooter. German semi-automatic designs, such as the G41 and later the G43, were intended to correct these limitations, yet they suffered from inconsistent performance, difficult maintenance, and production bottlenecks. Testing the Garands revealed the flaw at the heart of German thinking: complexity without industrial scalability, or sophistication without manufacturing maturity, was useless when measured against the practical realities of war. At Kummersdorf, the comparison between the Garand and German rifles became a lesson in contrasts. One test after another demonstrated that American engineering excellence was not merely a product of inventive minds, but of an entire system of production, standardization, and iteration. Each Garand operated reliably after exposure to sand, dirt, and heat. Each component fit within tolerances that allowed interchangeability without specialized tools. Each mechanism cycled smoothly after hundreds of rounds. In short, every test proved what American manuals, army reports, and field soldiers had already shown. The Americans had solved the problems German engineers didn't even realize required solving. It was not just about rate of fire or accuracy. It was about sustainability, reliability, and the ability to produce millions of rifles that would all perform identically in the field. The rifles themselves were unremarkable in isolation. There was nothing flashy, nothing revolutionary in their appearance. A walnut stock, a steel barrel, a gas-operated mechanism, and a simple rear aperture sight. The sum of their parts could have been conceived decades earlier. But what made these rifles extraordinary was not their design in theory, but their execution in practice. 4 million Garands would be produced by 1945, each functioning within remarkably tight tolerances, despite mass production at a scale previously unimagined. The Germans could look at one rifle in a test range and feel confident in its performance, but they could not replicate the guarantee of reliability across an entire army. In this, the significance of the Garand transcended the mechanics. It became a symbol of industrial might and disciplined engineering. What struck German observers most profoundly was the implication of American manufacturing capacity. Technical skill, design innovation, and battlefield proficiency, these had always been the metrics of military power. Yet here, in a small, perfectly functioning rifle, was proof that the decisive element of modern warfare had shifted. Production efficiency and industrial maturity had become as lethal as any weapon itself. No matter how advanced Germany's designs were, no matter how clever the engineers or bold the tactical thinking, the limits of German industry constrained every possibility. There were not enough factories, not enough trained machinists, and not enough raw materials to produce rifles on the scale, at the speed, or with the reliability that the Americans had already achieved. This realization was devastating to German confidence. Soldiers in the field fought bravely, tactically sound, and often with personal heroism. Yet they were equipped with weapons that, while formidable, could not match the systemic advantages of the American infantryman's rifle. Officers and engineers in Germany understood that the M1 Garand represented more than just a faster-firing weapon. It was a declaration of industrial dominance. It meant that the Americans could replenish losses, train replacements, and sustain combat operations without pause, while Germany could not. Every Garand tested, every round that cycled without fault, was a reminder that Germany had already lost the war of production, regardless of the fighting that still raged across Europe and North Africa. The psychological impact on the German officers and engineers cannot be overstated. For decades, German technical culture had prided itself on precision, ingenuity, and innovation. To see a foreign power surpass them, not with a single brilliant invention, but with the coordinated integration of design, manufacturing, and logistics, was unsettling. The Garand was a weapon that defied traditional measures of superiority. It was not about the skill of the shooter alone, nor about superior marksmanship or tactics. It was about a system in which skill, design, and production converged to create a reliably lethal tool in the hands of millions of soldiers. The M1 Garand also revealed a broader truth about the nature of modern war. Military conflict was no longer simply a contest of tactics, courage, or strategic genius. It was a contest of systems, of entire national industries, supply chains, and organizational structures. Germany could continue to produce elite units, deploy clever strategies, and fight with exceptional valor. Yet, each unit was ultimately constrained by the limitations of the tools they could wield and the numbers they could equip. The Americans, through weapons like the Garand, demonstrated a fundamentally different model, the merging of technical innovation with industrial scalability to achieve overwhelming operational advantage. By the time testing concluded at Kummersdorf, the officers and engineers were left with an unambiguous conclusion. The M1 Garand, for all its simplicity and commonality, was a harbinger of a new reality. German small arms development had followed a path that emphasized perfection in theory, brilliance in design, but never practical, reproducible performance at scale. The Americans, in contrast, had produced a weapon that worked, that could be manufactured consistently, that could be maintained in the field, and that could arm millions of troops with confidence. In this one measure, the trajectory of the war was clear. America's productive capacity, combined with engineering maturity, could not be matched, and every encounter in the coming years would be shaped by that fact. The Garand rifles tested at Kummersdorf were, in essence, silent witnesses to the coming defeat. They were unassuming, modestly styled, and mechanically straightforward. Yet they carried with them a story of industrial inevitability. They proved that wars could be won before bullets were ever fired, not solely by valor or strategy, but by the ability to design, manufacture, and supply a fighting force with weapons that would perform reliably day after day, battle after battle. And for the Germans observing them, the lesson was inescapable. The battle for technological skill had already been lost, and the greater struggle, the war of production and engineering maturity, was already decided. In the end, the M1 Garand was not remarkable because it was a single weapon, but because it represented a system of warfare in which practicality, consistency, and scale outweighed theoretical sophistication. In that truth lay the real power of American arms and the reason why, even as German troops fought valiantly across deserts and forests, the industrial war had long since been lost. Up next, we have two more incredible stories that are waiting for you. Just click the image you want to watch and it will take you there. If you enjoyed this video, make sure to subscribe. It would mean a lot.